Chapter 8, Section 8.1, Math 103. In this section, we want to calculate proportion of the population. So let's say you have a large cities and you want to calculate proportion of, let's say, all the people with medium income. So in that case, if we actually have tools and sources to measure, to go to every household in this city and ask them about their income and find the value, then that would be a mean or proportion of population, because you consider entire population into your calculations, which we normally use the capital P, proportion of populations. It could be any proportion. It could be proportion of people who actually vote. You want to know what is proportion of people who actually vote to one of the representatives within this city. So in that case, since we don't have all the sources and tools, we take a sample. For instance, we go in one part and we take sample of 20. We randomly select 20 family and ask them about their income, and then we calculate the proportion of that, which is we normally use like a p hat. And then we go to another area and we take another 20. One thing is you want to make sure that size of the sample remain the same. Means if you select 20 from this section of the city, you need to do the same thing here and everywhere. So when you take all these samples of 20, for each you calculate the proportions. So statisticians have come up with the result that when you do that, when you calculate the P proportion for each sample or for each group, and then you take the average of all this, that is normally is what the population is. So here, so in this section, a sample proportion, we show that with this symbol, it has a hat on, and the capital P is the population proportion. And then there is an example in the textbook in page 403, which here, fracking is a process of injecting liquid into the groundwater in order to fracture rocks. So what we did here, we consider a small population of 100. Well, let's just assume that there is a population of 100 Americans in one place, and you ask their opinion, whether they agree or oppose to fracking as a way to increase production of natural. So when you take a sample of 100 and ask their opinion, you notice that 40 of them are opposed and 60 are not opposed. So what is the proportion of people who oppose? 40 divided by 100. So proportions of population, for instance, is 40% or 0.40. Now, to see whether when we take a sample or close to that numbers or not, we go ahead and take 50 samples of 20. Okay, so first we randomly select 20 people and ask them about their opinion, and 5 out of 20 opposed. Then we go ahead and take another 50 samples and their opinion and calculate proportion for those. 7 out of 20 are opposed. So we keep doing that, and we collect 50 samples. Each sample that we collect, there are 20 people in it. So it's like, so you have 50 samples from one area, you take 50 samples. When you take the 50 samples, then you try to have a histogram, and this histogram basically is on relative frequency versus sample proportion. The part which is yellow is what the proportional population is. Remember, we said proportional population is 40% or 0.40. That's when you take a sample, some of the samples proportions is less, some of it is more. So we kind of come up with a table that we put the proportion and then we put the frequency, like how many of samples have proportion of 0.2? There were 2 of them. How many was 0.25? 5. Based on that, we calculate relative frequency, and when we calculate relative frequency, then we draw that histogram, like 0.40. See, if you notice here, the only 0.40 is here. Just one sample out of 40, oh wait, there is 1, 2, I'm sorry, I'm talking about the largest one, 0.65, sorry. This one, there is only 1. There is only 1 sample that proportion is 0.65. So 0.65, there is just 1, which when we calculate the relative frequency is almost 0.02. So that's what you have here. See, for 0.65, you have almost 0.02. So this is a histogram that on horizontal axis, you have sample proportion, and this is the relative frequency. All right. So now, then on the first part of the homework, the first set of the homework, the problem, I think 8.1, there are 2 histograms. Which one is better? They want to show you here that if the number of samples increase, the better it is. It's better to increase number of samples, okay? So in that case, your samples, all the numbers are getting clustered around the actual population proportion. So if the population proportion is 0.55, if you take a larger sample, like 75 instead of 50, you get a better graph here. So you see all the proportions are getting closer. There is no large variations here. Variation is less when your number of samples increase. So that's one thing is important, that when you take a samples, you want to make sure that the larger sample, the better it is, the better result is. So instead of 50, it's better to take 75. Okay, so, and then this is another example, shows that you have 40 samples here, you have 70 samples, see? So in that case, for 70, there is less variations. So these problems, I put a solution for you. And section 8.2, what section 8.2 is dealing is, I'll go through all this very quick because you have it. This is the important part on section 8.2. Mean of proportion, when you take so many samples and you calculate proportion for each, when you take the average of that, that actually is equal to proportion of populations. The proportion of population is equal to mean of proportion of the samples. A standard deviations is from this formula. N is the size of the samples, P is, which is equal to P of hat in this case, is the proportions. When N is large and P is not near to 0, 1, the sampling distribution is normal. So it's important to remember that these proportions, this P, must not be close to 0% or 100%. And it must be large in order to have a distribution which is normal. It's like a bell-shaped normal. One of the conditions is you want to make sure that sampling distribution is normal if 2 conditions are met. N times P has to be greater than equal to 10, N times 1 minus P also must be greater than equal to 10. These are 2 conditions that we need to have in order to have a normal distributions. So based on that, see here, they're telling you if your sample size is 30, 50, 30 is kind of minimum. 30, 50, 120 is better than 20. So we normally have sample size of 30. 30 is a minimum to use. Okay, so let's just go on this. In this example, it shows you how to use the standard deviation for each case. See, when you have the n and the mean and the standard deviation, you could calculate it here. So this is a good practice for you in this homework problems. Now on section 8.3, they ask us to calculate the standard deviation. Again, the standard deviation is proportion times 1 minus p divided by n. Now, you understand that in this formula, if the value of n decrease, the standard deviation increase, because this is at the denominator. Denominator decrease, standard deviation increase. So what I did, I kind of summarize chapter 8 here. When we ask you to find a standard deviation, this is a formula to use, okay? Now, we also have, they call it margin of error. When you calculate the proportion for a population, that proportions may not exactly be equal to proportion of population. There is always a plus or minus. For instance, let me give you a very simple example. Let's say you have the salary of one particular position is $30,000 a year. And you do your calculation, you come up with several numbers, and one number is like 28,000 and one number is 33,000. These two numbers are not exactly 30,000, but 30,000 always fall between these two. So in that case, we always claim that our population proportion is between two sample proportions. So for that, this is a formula to use. Proportional population, if you want to find proportional population always falls between sample proportion plus E, sample proportion minus. What is E? They call it marginal error. Normally in the problems, you have 1.96. This is for 95%, or we normally use 2. So to find the margin of error, you have to find a standard deviation first from this formula. So you calculate the standard deviations, multiply that by 2, that gives you the E. And then you take that and add and subtract from sample. That would be the range for proportional population. So proportional population, or capital P, is always between proportion of the sample plus or minus E. And here, 95% of all the possible random samples will produce a sample proportions. Where do we get it 1.96? When you have 95% confidence. In that case, your z-value, the z-value that we normally calculate the problems, is 1.96, which can round it to 2. And then before you actually work on the problems to see if the graph is normal, normal means like this. It's not like a scoot to the right or scoot to the left. In that case, there are two conditions. You want to make sure that n times p and n times 1 minus p both are greater than 10. We call this, sometimes they call this proportion number of success, and 1 minus p is number of failure. For instance, if I say 40% of people oppose and find probability of people who oppose, that would be your probability of success. And subtract from 1, which is 60% are not agree, or they don't oppose with that rule or whatever it is. When n is large and p is not too near 0.1, the sample is always normal. and we also showed in this example here. This is another example. So P hat is always X over N. 26 out of 48 people. Here in this example, see? 26 participants out of 48. So that would be your P hat. 26 out of 48. They ask us to find a standard deviation. You calculate that. To find margin of error, whatever this number is, you multiply by 2, and then that would give you the range for populations. The range of populations. Okay, and I think these examples are just following that. And I did problem number 5 and 6 here for you too. So again, they all are very similar. You find the P hat first, which is proportion of the sample, and which is X over N. Then you find the standard deviation and multiply by 2. That gives you the E, margin of error. E, margin of error, is 2 times the standard deviations, which in number 5, they're asking if this is greater than 0.01 or not. Yes. And then other one, I think this is problem number 6. They ask you to find the range for proportional populations. So that would be end of chapter 8.